Namaste student, this is Sanjay Nath. Today's session is on the Geography Grid System Latitude and Longitude Chapter 2 Part 2 Standard 9 ICSE. In this session we learn about what is time zone, world time zone, standard time, local time and how to calculate time followed by Great Circle Route. Now we'll see the time zones of the world. As you can see, there is a world map showing 24 time zones and each time zone equals to 15-degree longitude. There are many countries those who have more than 2 time zones. With the help of observation, one can make it out which country is having more than 2 time zones. I can give you one or two examples like Russia is a big country, North America or United States of America and China. Now we'll understand the relationship between longitude and time. As you know that the world rotates or spins on its own axis, it takes 24 hours to complete one rotation and that equals to 360 degree. Now 360 degree divided by 24 hours equal to 15 degree per hour. It means in 1 hour on its own axis Earth covers 15 degree longitude. The world has 24 time zones and each is of 15 degree apart. Therefore, a 1 hour time difference for every 15 degree of longitude. Now we'll watch an animation on longitude and time, what time it would be on different longitude. If it is 12 noon in England, on the same longitude, opposite side, midnight next day in New Zealand. If it is 3 p.m. in England, on the same longitude, opposite to that, 3 a.m. next day in New Zealand. If it is 6 p.m. in England, on the same longitude, opposite to that, 6 a.m. next day in New Zealand. And this is 1 year of observing or calculating time on different longitude, keeping in mind the GMT time in UK at Greenwich. Now we learn how to calculate time with the help of longitudinal position of the places. As you can see, there is a Mercator map in front of you, and this map is showing some location with the help of black dots Z, D, C, B and X. Find the time for these locations with reference to D. Now let's have a look. The question is, if it is 9 p.m. at position D, what would be the time at position C and B? As you know that the longitudinal difference in time 15 degree equals to 1 hour, and from 0 degree D C point it is of 60 degree longitudinal difference. It would be definitely the time at position C would be 5 p.m. Now if we calculate the time from 0 degree prime meridian on the western hemisphere at 90 degree, the time difference would be 6 hours. The time would be 3 p.m. In this manner one can calculate the time from one reference point to other reference point. Let's understand with the help of another example. If it is 1 p.m. at position D, at which location is the time 5 p.m.? As you know that every 15 degree longitude equals to 1 hour. If it is 1 p.m. at position D, so definitely the place is ahead of D. Now we calculate it is about 4 hours ahead. So it is around 60 degree latitude and the position is Z. Now we'll understand what is local time. Time is to adjust the clocks at the noon time, when the sun would cross the local meridian and the shadow would be at their shortest. As you can see in this diagram, a stick has been installed on the ground and you can see the position of the sun at 1, 2 and 3. No, don't get confused. These are not 3 suns. These are different position of sun at different time. Now at first, the position of the sun is at the horizon at early morning, eastern side. As you can see, the shadow of the stick falling towards certain direction will be around 8 a.m. The shadow is little bit elongated. When the sun position change from 1 to 2, as you can see, it is exactly over the stick overhead or zenithal position. The shadow of the stick will be little bit shorter. It will be around 12 p.m. is the noon time. This is the time when it is considered to be the local time of the particular place or the meridian. Now you can see the position of the sun at 3 and from here the shadow falling on the ground is at 15 p.m. 3 o'clock in the evening and the shadow is little bit elongated. In this manner one can declare that at 12 noon when the sun is exactly over the head, that time is declared as local time of the particular place or on that particular meridian. Thus the time calculated by the position of the sun at the noon at the given place is called the local time. Now we'll understand what is local time with the help of a video clip. Time is eternal. One place is dusk, evening. Some other place in the midnight. Time goes on. Star also changes its position that one can see at the midnight sky. One day is the time passed between two peak position of the sun. Local time. Local time of the place is been derived from the midday position of the sun on a particular meridian or longitude. As you can see, line of longitude called the meridian has been highlighted. Earth completes one rotation in 24 hours. Every 15-degree longitude equals to 1 hour. From prime meridian on the eastern hemisphere, if you count 1 degree longitude, there is total of 4 minutes difference. Now we'll understand why many countries doesn't follow the local time as their primary time for dealing with everything like transportation or booking. The reason behind, from one part of the world or one part of the same country, if the train starts at particular time, there would be a problem of booking of the train from a different place. To avoid this confusion, a country follows a standard time that is mainly based upon the local time of that particular place or a region being considered to be as standard time. Now we'll understand what is standard time. To avoid the confusion of time based on local time, with the help of international agreement, the local time of standard meridian linked to GMT. For example, GMT is the standard meridian time for England. The best example to understand the standard time will take India. As you can see, the standard time for India has been fixed is 82 degree 30 minutes east longitude. As you can see, this black dotted line is passing over Allahabad, very close to Mirzapur, is considered to be the IST or Indian Standard Time line. So this 82 degree 30 minutes east longitude is considered to be the standard meridian for India. This particular standard meridian in India is 5.5 hours ahead of GMT. The reason, India is located on the eastern hemisphere east of 0 degree prime meridian and is ahead of 5 hours 30 minutes of GMT. Now we'll see why we have taken or considered 82 degree 30 minutes east longitude as IST. India span between 68 degrees 7 minutes east longitude to 97 degree 25 minutes east longitude. Approximately the span is 30 degree longitude. Now it is very convenient to divide India into two equal longitudinal part, 15 degree on the east of IST and 15 degree on the west of IST. In this manner, India is having one standard time zone. Now we'll understand international date line. International date line is 180 degree. It separates two calendar days. As you can see in the sketch, international date line is drawn in red color and is exactly passing over the Pacific Ocean. Now why it is zigzag, that we'll discuss after some time. Now why the need of international date line? In 1519, Ferdinand Magellan started the voyage around the earth and in 3 years circumnavigate the earth. During the voyage, they realized the importance of the day and the correct date. Later, the establishment of international date line has been considered. As you can see, this international date line 180 degree is just opposite of 0 degree prime meridian. This particular longitude is 180 degree longitude just opposite of 0 degree prime meridian. It passes over the Pacific Ocean. Both 180 degree east and 180 degree west are actually the same meridian. America to Asia, gain a day, and Asia to America, lose a day. Now we'll understand how the meridian be 12 hours ahead and 12 hours behind GMT. As you can see, international date line shown with the help of dotted yellow line. And this is not straight, this is zigzag and is passing over Pacific Ocean. You can see some names, Fiji, Tonga, very close by Australia, and one more name, Samoa. Now this line is zigzag. Now what is the idea behind keeping the line zigzag? If the line is passing over any island country, there will be confusion of two dates. To avoid any confusion of two dates in a particular country, they have drawn this line little bit deviate, or you can say in a zigzag manner. In future, this white dotted line will become the future date line. It will take Samoa towards eastern hemisphere. The key advantage of ideal. The ideal is the middle of time zone. Thus, there is no hourly change at that point except the change in date. Ideal don't follow the 180 degree exactly that I've already told. The line is drawn zigzag as per the location of group of island and the country to avoid any confusion of date. Now we'll watch a video clip to get more insight on international date line. As you can see, a globe and the green color has been drawn on 180-degree line that represents international date line. This line is zigzag. Monday, 1 day ahead. But this thick green color is representing the international date line. As you can see, it is passing over Pacific Ocean. At this point, it is shown in red color. In future, this would be the international date line. We'll consider some of the countries or island countries. Western Hemisphere 1 day behind, Eastern Hemisphere 1 day ahead. Now, how to locate places on Earth? Scientists have established a coordinate system, Earth coordinate system, based on lines of longitude and latitude. It always measured in degrees, minutes, and seconds. North or south for latitude, east or west for longitude. As you can see, equator here, and one latitude has been drawn in northern hemisphere, and this angular distance represents the latitudinal position. This can be understood further with the help of this sketch. Latitudes are drawn horizontally north of equator. The latitudinal distance is shown in degrees, minutes, and seconds. The angular distance shown with the help of latitude and longitude. The latitudinal position has been shown from equator towards northern hemisphere. The angle is 55 degree 30 minutes 00 seconds north. And the angular difference from 0 degree prime meridian towards the eastern hemisphere is 60 degree 00 minute and 00 seconds east longitude. In this manner, one can locate places on Earth, and this is called the Earth coordinate system with degrees, minutes, and seconds. Now we'll understand the great circle and small circle. All lines of latitude except for the equator and the two poles are small circle. These are some interesting facts about great circle and small circle. The center of the great circle is the same as the center of the sphere. The great circle can be aligned in any direction of the sphere, but one thing you have to keep in mind, the great circle will be drawn keeping in mind the center of the sphere. The great circle can be drawn to include any 2 points on the Earth's surface. As you can see in this sketch, the 2 points shown over here, P and Q, and it completes one great circle and keeps the center of the Earth in consideration. Great circle is always favored by the aviation industry. They always follow the path of great circle to save fuel and time. Thank you for watching the presentation.